2020 will be a banner year for the exploration of Mars. In addition to the launch of NASA's Mars 2020 rover, the European Space Agency and Roscosmos are sending the ExoMars Rover to the Red Planet. As it descends from its landing platform, ExoMars will embark on an enterprising mission to uncover buried signs of past or present life. The Martian surface is a harsh environment, bombarded with cosmic radiation, but the subsurface could offer better protection. For this reason, ExoMars is equipped with an extending drill that can retrieve samples from up to 2 meters below the surface. Studying these samples will be the job of the Analytical Lab, a trio of instruments designed to search for the molecular fingerprints of life. The Mars Organic Molecule Analyzer, or MOMA, is the largest and most complex instrument on the rover. Its mass spectrometer subsystem and its main electronics were built and tested at NASA's Goddard Space Flight Center, which also contributed mass spectrometers to NASA's Curiosity rover and Maven orbiter. MOMA is designed with a mix of proven hardware and innovative new technologies. Here's how it works. In gas chromatograph mode, crushed Martian rock is put into an oven and heated to 900 degrees Celsius in just 2 minutes, vaporizing the sample. Molecules of hot gas rise up and flow into a narrow 20-meter-long tube. Special coatings inside the tube cause molecules with certain chemistries to slow down more than others, separating the mixture of molecules over time. Next, a beam of electrons ionizes the molecules, giving them a positive electric charge and deflecting them towards the linear ion trap. The ions are caught by a fluctuating electric field and sent to a detector to determine the chemical makeup. While gas chromatography has been used to study Mars since the Viking program, MOMA has a second method for preparing samples that has never been used on another planet. In laser desorption mode, a sample is placed beneath a powerful ultraviolet laser. A beam of energetic light builds within the laser and fires in a billionth of a second, concentrating its energy onto a spot smaller than a grain of sand. This rapidly vaporizes a portion of the sample, releasing large organic molecules that could be broken down by oven heating. The laser shot also ionizes some of the molecules, allowing the vapor to head directly to the linear ion trap. Neutral molecules are ejected by a vacuum, while the remaining ions are sent to the detector to determine their chemical makeup. Laser desorption will enable MOMA to detect long molecules, like lipids, the building blocks of cell membranes, a leap forward in the search for life on Mars. MOMA's linear ion trap is another first for the Red Planet. It will scan for the fingerprints of life using techniques normally confined to laboratories on Earth. One technique, called SWIFT, repeatedly ejects unwanted molecules from the trap. Over time, this builds up molecules of interest, improving detection. Another technique is tandem mass spectrometry, or MSMS, which identifies large molecules by breaking them apart and analyzing their fragments. By combining SWIFT and MSMS, MOMA can determine an individual molecule's formula and its structure, both important criteria in the search for life. The question of life on Mars is among the most important in planetary science, and the evidence may be buried just below the surface. With the help of MOMA, ExoMars will take us one step closer to uncovering the answer.